Welcome, architects and developers. Today we are diving into a foundational pillar of enterprise AI, leveraging JSON schemas to guarantee structured, predictable outputs from Claude. Let's get started. Let's begin by defining how Claude interacts with structured data. Out of the box, LLMs are conversational. They want to chat and explain things. But in enterprise architectures, your downstream databases and APIs cannot parse friendly conversational text. They need strict, predictable JSON structures. We bridge this gap by leveraging JSON schemas. A JSON schema acts as a rigorous instruction manual that tells Claude exactly what data types, keys, and formats are expected. By placing this schema inside the input schema of a tool definition, you force Claude to conform to your backend requirements. This fundamental shift allows you to move from fragile regex parsing to robust, autonomous data extraction pipelines. Look at this flowchart to see the data transformation. On the left, we feed Claude our messy, unstructured prompts and documents. Crucially, we also inject our strict JSON schema definition. Claude processes these inputs and, bound by the schema, outputs a highly predictable JSON structure that flows seamlessly into your downstream APIs and databases without breaking. A highly tested concept on the certification exam is how to design your schemas defensively. Imagine you are extracting data from an invoice and your schema requires a purchase order number. What happens if that specific invoice doesn't have a PO number because the schema strictly demands it? Claude might hallucinate a fake number just to satisfy your rigid validation rules. To prevent this hallucination trap, you must design your schema with optional or nullable fields. By defining the field type as an array containing string and null, you give Claude a safe escape hatch. If the data is missing, Claude confidently returns null instead of guessing, drastically improving the reliability of your extraction pipeline. This state diagram illustrates the hallucination trap. During data extraction, Claude encounters a missing field. If your schema configured this as a strictly required field, it forces the model to guess, resulting in a hallucination and data corruption. However, if you engineered it as a nullable field, Claude safely returns a null value, maintaining high data reliability. Another essential schema design pattern deals with categorization. Let's say you want Claude to categorize documents into invoices or receipts using a JSON enum. What happens when a user uploads a credit note? A rigid enum without fallback options forces Claude to incorrectly label the credit note as an invoice or receipt. The architectural best practice here is the other plus detail pattern. You always include other or unclear as a valid enum option. Then, you pair it with an accompanying detail string field. If Claude encounters an unexpected document type, it safely selects other and uses the detail field to explain exactly what it found. This prevents silent misclassification and handles edge cases gracefully. Watch the routing in this flowchart. When our system processes an unexpected credit note, a rigid schema without another option leads to the red node, forced misclassification. But by using our extensible pattern, the logic flows to the right. Claude selects the other enum and populates the supplementary detail field, safely handling the edge case. Even with a perfect JSON schema, Claude might still try to be conversational and output plain text explaining the data. To prevent this, we use the tool choice parameter to force structured output. The auto setting lets Claude decide if it wants to use your schema. The any setting forces Claude to use at least one tool from your list. But for pure data extraction, you want forced tool selection. By passing an object with the specific name of your extraction tool, you completely bypass the AI's decision-making engine. You guarantee that Claude will not output conversational pleasantries, but will instead immediately output a tool use block strictly conforming to your JSON schema. This guarantees structural compliance for your pipeline. This sequence diagram maps the forced execution flow. Your application sends the document and the forced tool choice parameter. Notice what happens next. Claude explicitly bypasses its normal conversational logic. It immediately responds with a tool use block containing your strict JSON, allowing your application to parse the data safely and predictably. Now we arrive at one of the most critical exam topics, the semantic trap. It is vital to understand that forcing tool use with a JSON schema guarantees structural compliance, but it does not guarantee semantic correctness. What does this mean? It means your output will have all the required keys, no missing commas, and perfect string/number data types. However, the actual values inside might be completely wrong. Claude might have extracted the shipping date instead of the invoice date. A major anti-pattern is blindly saving schema-compliant JSON straight to your database. You must build a separate business logic layer in your code to validate the semantics, like checking if the extracted line items actually add up to the stated total. Structure does not equal truth. This flowchart highlights the semantic trap. The output easily passes the green schema check because tool use guarantees structure. The dashed line shows the dangerous anti-pattern of saving it immediately. The correct, robust architecture forces the data through the orange business logic check, rejecting mathematically or factually incorrect data even if its JSON formatting is flawless. When your semantic validation catches an error, how do you fix it? You implement a validation retry loop. Your system programmatically sends the document and the failed JSON back to Claude for self-correction. The golden rule here is specificity. The biggest mistake developers make is sending a generic message like, "There were errors. Please try again." That gives Claude zero signal on what to fix. Instead, you must append specific, calculated feedback. For example, your extracted line items sum to $450, but the subtotal field says $500. This explicit feedback guides Claude directly to the error, drastically increasing the success rate of the retry. However, remember the limits of retries. If the data simply isn't in the source document, no amount of looping will make it appear. Let's trace the validation retry loop. Output enters the semantic check. If it fails, we move to the bottom path to generate a specific error, like a total mismatch. We append that precise constraint to the prompt and retry. Notice the red anti-pattern node. Never feed a generic "try again" message back into your loop, as it leads to infinite failures and wasted tokens. To tie this together, consider an automated overnight invoice processing pipeline handling 10,000 documents. First, we design our schema defensively, using nullable fields for missing data and extensible enums for weird document types. Next, we use forced tool choice to guarantee strict JSON output. Because this is an overnight, non-urgent task, we architect this through the Message Batches API, which nets us a massive 50% cost savings. Finally, our code parses the JSON and runs semantic checks. If the math fails, we trigger a specific retry loop. If model confidence is low, we route it to a human reviewer. This is how you build enterprise-grade structured data extraction. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you. This final architecture summarizes our production pipeline. Raw invoices hit the cost-effective batch API, flowing into our forced schema extraction. The resulting JSON hits our semantic validation layer. Errors route to specific retry loops, ambiguities trigger human review, and only verified, semantically sound data makes it to your production database.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.